Hello, everyone. Welcome to our presentation today. My name is Lucy Lee. I'm an extension entomologist in the University of Arizona. So my co-author, Africa, is the pesticide program manager for the Intertribal Council of Arizona. We really appreciate this opportunity today to talk about the IPM for microorganism pests. First, just a brief introduction of our programs. I coordinate the University of Arizona Public Health IPM leadership team, which serves as an executive committee to guide the development and implementation of public health IPM program. So the team includes experts from diverse fields relevant to public health pests, vector-borne diseases, pesticide risk reduction, and food safety. So the goal of our UA Public Health IPM program is to develop and implement priority engaged research and extension public health programs statewide. Currently, we work in 4 focus areas: IPM in tribal communities, vector control, especially mosquito and tick control, implementation of IPM in schools and housing, and food safety, particularly produce safety. Africa is the pesticide program manager for the Intertribal Council of Arizona. So in her current capacity, Africa manages and administers the ITCA pesticide enforcement and the worker safety program. She provides technical assistance, outreach, and training to tribal staff in pesticide safety, worker protection standard, and integrated pest management practices. So first, let's start with what is a pest. Pests are organisms that can damage crops, homes, and other structures, or interfere with desirable plants, impact human or animal health, and they can also reduce the value of collectibles. So they may transmit the disease or may be just a nuisance. So in short, pests are organisms that are out of place. So you may see some familiar ones on these slides. A pest can be a plant, vertebrate, invertebrate, nematode, pathogen, and other unwanted organisms. So plants, for example, weeds growing in your lawn grass or turf grass. So those are the plant pests. Vertebrates, for example, pigeons and other birds, Canadian geese or geese or ducks, and also rodents. Rodents are very common vertebrate pests, including house mice, roof rats, and Norway rats as commensal rodents. And termites are insects. They are invertebrates. They can damage structures. And mosquitoes can transmit, disease-causing pathogens. They can be a vector, and also ticks and mites and snails as well. So sometimes birds can be a pest. For example, you have seagulls around in the coast areas, and they try to get your sandwich from you as their lunch. And also sometimes your pets can become a pest. For example, this is my little pet Jojo. He actually destroys my daughter's homework. He actually eats them. So when your kids tell you, my dog eats my homework, that sometimes can be true. When that happens, your pets can become a pest. So here in this lecture, we're mainly focusing on microorganism pests or pathogens. That includes bacteria, viruses, parasites, or fungi. So bacteria are microorganisms made of a single cell. They are very diverse, have a variety of shapes and features, and have the ability to live in just about any environment, including in and on your body. So not all bacteria cause infections. Those that can cause infections are called pathogenic bacteria. So bacteria can multiply both inside and outside of a host. Bacteria that have been associated with produce outbreaks, including pathogens such as E. coli, O157, H7, Salmonella, Shigella, and Listeria. They can multiply rapidly given the right conditions, for example, water, food, and the proper temperature. So if conditions are ideal, bacteria can multiply once every 20 minutes. So it is unlikely you will ever start with just one bacterium. So good agricultural practices can reduce risks by minimizing situations that support bacteria survival and growth. And antibiotics, as we all know, in humans, antibiotics are used to treat bacteria infections. So viruses are small particles of nucleic acid that require a host in order to reproduce themselves. So viruses are typically spread by people, such as food handlers who have not washed their hands before touching produce or food. Examples of viruses associated with fresh produce outbreaks and illnesses include norovirus and hepatitis A. Only a few virus particles are needed to make someone ill, and they are very easy to spread through the environment and from person to person. So you may be familiar with norovirus because of its association with cruise ship outbreaks and its ability to spread rapidly in tight quarters. So prevention is the key to reducing the spread of viruses. So basic hand washing, proper restroom use, and illness reporting can help prevent the spread of these viruses. So the research on the reduction of norovirus on food contact surfaces is currently limited. So making selection of a sanitizer effective on viruses is very difficult. So growers should focusing on preventing contamination from occurring in the first place. So parasites are organisms that behave like tiny animals, living in or on a host and feeding from or at the expense of the host. So though parasitic infections are more common in tropical and subtropical regions, they can occur anywhere. So parasites need a host to multiply, but they can also be very stable in the environment. They can remain variable in the environment for long periods of time and are often transmitted through water contaminated with fecal material. Examples of parasites associated with produce outbreaks would include Giardia, Toxoplasma, and Sacklose. So crypto, which is a leading cause of waterborne disease among humans in the United States. So more than 48 million people in the United States may be infected with the Toxoplasma parasites. And some parasites can survive in the body for a very long period of time without producing any symptoms. So this makes it super difficult to know when, where, and how the individual became infected. And sometimes symptoms may also come and go, so making the parasite infections difficult to diagnose. There are millions of different fungal species on Earth. Just 300 also are known to cause sickness. So fungi can be found just about everywhere in the environment, including indoors, outdoors, and on human skin. They cause infection when they overgrow. So the common fungi we know include yeast, molds, and as well as the more familiar mushrooms. So fungi acquire their food by absorbing dissolved molecules, especially by secreting digestive enzymes into their environment. So they don't photosynthesize. So many fungi are parasites on plants, animals, and other fungi. Some fungi can cause serious diseases in humans, several of which may be fatal if untreated. And some fungi can cause serious diseases in humans. We will talk about that later. So here, CDC has a new warning about a drug-resistant and a potentially deadly fungus has been spreading rapidly through the United States healthcare facilities. So the fungus generally can be found on the skin and throughout the body. According to the CDC, most times they are not a threat to healthy people, but this newly funded strain of fungi can cause 1/3 of the people who become sick and sometimes cause death. This is also this strain called Candida auris. Now it's, this fungi has now been detected in more than half of the United States. Some are new strains can provide to be especially dangerous, and they can have more problems in the healthcare facilities, and it can, especially for the people with weakened immune systems. So we're going to talk about, first of all, we're going to talk about pathogens in produce safety. So as previously mentioned earlier, there have been a variety of pathogens which have been associated with fresh produce outbreaks, including the bacteria pathogens, viruses, and the parasites. So though many may experience only minor symptoms such as diarrhea, nausea, or vomiting, others have more serious symptoms that result in hospitalization, long-term health impacts, and even death. So here, this slide shows the health impacts by pathogen types. This is based on the FDA outbreaks linked to produce safety produced by pathogen types from 1996 to 2014. As you can see, there are about 172 produce-related reported outbreaks occurred during those period of time, and resulting in 17,156 outbreak-related illnesses and over 2,000 hospitalizations and 68 deaths. And also in this picture, there's also include a chemical hazard that was linked to the consumption of squash in 2002. As you can see here, bacteria is the most commonly pathogen type that can make people sick. So produce safety can be challenging for a number of reasons. So many of the fruits and vegetables are consumed raw, which means there's no cooking or killing steps to destroy pathogens that may be on the produce. So the contamination events are often sporadic, affecting very small portions of the crop. So knowing contamination has occurred is very difficult. Microorganisms also, as their name suggests, are not easily seen. You cannot really see them with your naked eyes. So the contamination is difficult to detect, virtually. Contaminations also usually present at very low levels. Rough surfaces, for example, cantaloupes, cantaloupes has lots of those little rough surfaces, and also the large folded surface areas, for example, the leafy greens, there's a huge amount of those areas that can harbor, pathogens or bacteria, on the body. And also some of the plants have stem scars. For example, the tomatoes, it has a stem scar. So once the pathogens or bacteria stay on the stem scars, it's really hard to remove them. So therefore, making pathogens difficult to remove by any amount of washing at the farm level or in the consumer's home because of those conditions. So for those reasons, the focus of produce safety is on preventing contamination from occurring in the first place. Contamination is difficult to remove once present. Therefore, produce safety is really critical for growers and farmers who grows fresh produce. So on a farm, contamination can come from a variety of sources or number of sources, including humans, animals, soil, water, and buildings, equipment, or tools. As you can see from this slide, humans can carry pathogens and spread them to produce food contact surfaces or other people while they work on the farm. So pathogens are most commonly spread directly or indirectly by fecal material through fecal-oral route. That means, the E. coli or pathogens that exist in the fecal or poops. And people touch it and then by accident they will eat it. So that's the fecal-oral route. But they can also spread through the saliva and other bodily fluids. For example, the blood can transmit the bloodborne pathogens. So the workers who directly contact produce through activities, for example, harvesting activities and the packing activities, have the highest potential for contaminating the produce. Domesticated and wild animals or wildlife can carry and transmit human pathogens to produce. Field in children may result in direct fecal contamination of crops and fields, and also animal feeding, rooting, and movement through the fields may spread the contamination as well. And also animals can contaminate water sources used for produce production. Manure runoffs can also contaminate the fields and water sources and the crops. So the raw manures and other soil amendments can be a source of contamination if they're not properly handled and applied. As you can see here, applications too close to harvest season and improper or incomplete treatment of the raw manures, improper storage of the compost or manures, runoff and the wind can also spread the cross-contaminations due to their improper sanitation procedures. And also, raw manure represents a significant microbial risks to fresh produce, since animal manures can contain human pathogens. So water, including the production water and the post-harvest water, can carry and spread human pathogens, contaminating the entire fields or large amount of produce. When there's water events, for example, if your water, the irrigation water has been contaminated by feces, and it will make, contaminate the fresh produce when they are touching all those fresh produce when you are watering the field. And also the most commonly overlooked sources will be, the buildings, equipment, and tools. Any unclean surface that contacts produce can harbor pathogens and serve as a source of contamination. So when that happens, that's also including the pest management, equipment that you are using, facility management can also impact the risks. For example, the areas outside of the building that not kept mold or clean can serve as pest harborage areas, and those little wildlife or animals can come inside the building, standing water or debris in the packing areas can become a source of cross-contamination. So all those could contribute to the produce safeties and also the pathogens in the produce. So think about it, the growers or facilities have those things on their farms or facilities. As you can see there, there's a feces on the toilet, not sanitized, not clean toilet. When you touch it, it will become fecal, oral sources. And clothing that also includes that guy is feeding the chicken, and then may contaminate it by those feces, and then when he go to collect those fresh produce behind him in that greenhouse, it could be a route of contamination. And hands, dirty hands in that picture, not only dirty hands, and also there are pathogens as well on the hands. If you have workers or any of your family members who are handling fresh produce, you want to make sure their hands are clean. And overlooked part would be footwear. Many people may not realize, the pathogens can actually stick on their footwears if they, walk around the contaminated areas. So always make sure, the people wears clean, sanitized footwears. And tools and equipment, because you're using the tools to harvest the produce. If the tools or equipment that are contaminated, as you see in that picture, if they use a knife to harvest the lettuce, if there are some blood contaminated the knife, it will also potentially introduce some hazards in that situation. So all those will be concerns when you are dealing with fresh produce. Because as you can see, fresh produce are the one of the top reasons that can cause foodborne illness among humans. So all those routes of contamination could be contribute to that. So now we're going to talk about microorganism pests in the built environment. So those will be will cover public health, pathogens in this slides in this session. So based on the CDC, there are also many other microorganisms of concern or pests in the built community environments, such as schools, homes, and medical facilities. So you may recognize many of these microbial pests on these slides. So the red column here are the illnesses caused by virus. As you can see, hand, foot, mouse virus, chicken, pox, measles, mumps. So the fifth disease is actually it's It's a mild illness caused by a virus called parvovirus B19. It is really rarely serious. Its most obvious symptom is the bright red rash or slap the cheek look of the face. And this disease often occurs during the winter, late winter and early spring, especially in children between the age of 4 and 10. And as you can see, those three diseases, 3 viruses in that frame, that including influenza virus, stomach flu, norovirus, and the COVID-19 might be the biggest concerns among all. And also here I want to mention ringworms. The ringworm is a fungal skin infection. So the fungus lives off dead tissues such as skin, hair, and nails. So they are scaly, crusted rash and may itch. So they also are zoonotic diseases, which means ringworms can transmit from animals to humans. So for some of the classrooms, if they have guinea pigs or other classroom pets that can that infested with ringworms, it will transmit to humans. So on the left corner, those groups are diseases caused by bacteria. For example, the impetigo is highly contagious. It caused by the straps or strep, bacteria. Generally, you will see the red sores on the face, around the nose, mouth, hands, and feet. And sometimes it can be itchy, and also sometimes the sore bursts, and they can develop the honey-colored crusts. So also there's the MRSA, methicillin-resilient bacteria. MRSA is responsible for several difficult to treat infections in humans. It can cause more than 100,000 deaths worldwide because they are resistant to the microbials. Especially in 2019, it caused over 100,000 deaths. So the MRSA infection is common in hospitals, prisons, and nursing homes, where people with open wounds, invasive devices such as catheters, and also the weak immune systems are at a large risk of healthcare-associated infection. And the C. diff is also a big concern because they can cause diarrhea and colitis, which is an inflammation of the colon. It's estimated to cause almost 500,000 infections in the United States each year. And plus the spores are highly resistant to the cleaning agents, and they can survive on the dry surface for a few months, like 5 months or so. It can be killed by chlorine bleach, and however, the best way will be isolate the infected individuals. So all those will be the microorganism pests or concerns in the built environment. So the norovirus is the leading cause of foodborne illness in the United States. So it causes 58% of the foodborne illnesses acquired in the nation. So each year, a foodborne norovirus illness or a stomach flu in the United States costs about $2 billion, mainly due to the lost productivity and the healthcare expenses. And also the norovirus illness is very contagious, and the sick staff and all those who care for others, if they are sick with the stomach flu or norovirus, they shouldn't prepare food. And also infected food workers cause 70% of the reported norovirus outbreaks. So that's why, make sure there's hand washing stations and also proper restroom clean and sanitation, and also make sure the workers are reporting could potentially reduce or limit the spread of this virus. So this slide shows transmission and the survival of pathogens in the food processing and the preparation environment. So there are many common pests in kitchens and the pantries that can carry and transmit pathogens. As you can see, we have those lovely critters here. There are cockroaches, rodents, flies, all those things that you don't want them in your kitchen or the pantries. So the pests love food service areas because they often have everything a pest needs to survive. They have food, water, and shelter. So you have all those three elements in one place. And of course, pests love it. So outbreaks frequently occur where food workers have been implicated in the spread of foodborne disease. So clean and well-maintained food service areas are essential for the health and well-being of all people who eat and work in the area. So food service staff are among the most important people in safe and healthy schools because they deal with food. So if you are working in the food settings, in the school settings, so make sure the food service areas is clean and well-maintained and free of critters and also other pathogens as well. So now we talk about, mitigating of the pathogens. Here we talk about management of microorganisms. What can we do to prevent or reduce the risks that are, getting sick? So introduce integrated pest management, IPM. So IPM may be used in schools for pests, such as, you use IPM method to get rid of weeds, exclusion, sanitation, and education, and base station, to get rid of rodents and cockroaches. There's sanitation, identification, and also some that use base station to get rid of cockroaches. We know IPM can be very successfully to remediate those pests. And also IPM principles can be used for addressing the microorganism pests. We already talked about bacteria, viruses, and fungi. So now how we can use the IPM principle to address those problems. Here we're going to introduce to recap what is a pesticide. So based on the EPA and other agencies, pesticide is any substance or mixture of substance that intended for preventing, destroying, repelling, or mitigating any pest. And also it is any substance or mixture of substances intended for use as a plant regulator, defoliate, or desiccate, and also any nitrogen stabilizers. So those are the definition of a pesticide. So a pesticide is a product, is a product likely to be considered a pesticide if you see those words on the labeling or the advertising. For example, if they make a claim to prevent, kill, destroy, mitigate, remove, repel, or any other similar action against any pest, so those products may be considered pesticides. And also it directly states or implies our action against a pest and draws a comparison to a pesticide and pictures a pest on the label. So that's why when you see all those claims on a product's label or advertisement, and those products will be considered a pesticide. And also, here's the info taken from EPA Citizens Guide to Pest Control and Pesticide Safety. There's always, signal words as to the severeness of the pesticides. For example, here we have caution, warning, and danger. Go with the color. Caution is a yellow color, means this word caution appears on pesticides that are the least harmful to you. So caution is the least harmful signal words here for the pesticides. So the warning is orange color, as here warning means a pesticide with the word warning is more poisonous than those with a caution label. So caution is the weakest and warning is moderate. And then danger, as you can see, danger is in right. So danger is very poisonous or irritating, so they should be used with extreme care because they can severely burn your skin and eyes. So when you're thinking about this, it's kind of like the traffic lights, green or yellow. Green means caution, warning, and danger. So those are the signal words. And if you see all those signal words, or sometimes on the pesticide label, you have to take precautions while you are reading the label and carefully follow the instructions on the label as well. So antimicrobial products, kill or slow the spread of microorganisms, including the bacteria, viruses, protozoans, and the fungi, and such as mold and mildew, and sometimes A product's label claims to kill, control, repel, mitigate, or reduce a pest. It is a pesticide, and they are regulated by the EPA. So the EPA regulates antimicrobial products as pesticides. So as pesticides, antimicrobial products are used on objects such as countertops, toys, grocery carts, and hospital equipment. And again, when you are dealing with antimicrobial pests and antimicrobial products, always read the label, and they have detailed instructions on exactly how to use those antimicrobial products because they are considered pesticides. So read the label. Label is the law when you are dealing with pesticides. So here we talk about bleach, and bleach is a common name for products that contain the sodium hypochlorite. Sometimes bleach can be a pesticide, a cleaner, or both. As you can see here, when bleach are considered a cleaner, it is generally, it's a general purpose cleaner or whitening agent. You may find bleach in the laundry detergent or, cleaning detergent agents. So bleach used on household surfaces and the laundry when you are using this. When in this case, this bleach, is not acting as a pesticide. So it does not require EPA registration. And when you see your laundry bleach in your laundry room, and you won't be able to find a EPA registration number for this case because it is not considered pesticides, so no EPA registration number. And the pest killing instructions will not be included on those labels when you are doing it. And however, bleach will be considered a pesticide when they are used to disinfect the surfaces or get rid of the ant trails or any other purposes. So the label will include the specific directions about how to use the product effectively. So because here the bleach will be considered as pesticides, you will be able to find a EPA registration number on the container. So check your bleach containers when you go home to see if you can find an EPA registration number. Generally, like I said, if the bleach used for laundry purpose, you won't be able to find a number. Otherwise, if a bleach as killing disinfectants, then the bleach you will be able to find a EPA registration number on the container. So do a treasure hunt after the presentation. Here, I also want to clarify the disinfectant wipes and also the baby wipes, because we did get questions from some of the parents. Can they use disinfectant wipes to clean or wipe their baby's rears? So disinfectant wipes, as you can see here on the left, EPA regulates, antimicrobial products, pesticides. Those are considered disinfectant wipes. They are considered antimicrobial products. Therefore, it's regulated by EPA. So when you check your disinfectant wipes container, you will clearly find an EPA registration number. No matter what kind of brand you use, you will always find an EPA registration number if they are considered disinfectant wipes. And however, if it's baby wipes, and baby wipes, they are, you can use on living things, the baby wipes or hand sanitizing wipes. You don't see disinfectant words on those labels. So it just kind of baby wipes, you can find it many brands, and you can find the containers. They are regulated by FDA. They are considered as drugs or antiseptics. So therefore, they are not regulated by EPA. You won't be able to find an EPA registration number on there. Therefore, baby wipes, you can use that on clean the baby's rears. However, do not ever use disinfectant wipes to clean baby's rears. Important things we said 3 times. So disinfectant wipes are considered pesticides. So therefore, do not use them on living things, non-living services. So that's why the definition of bleach and also the wipes. So based on the public health, those are the public health settings or non-public health settings. As you can see, there are a few types of antimicrobial pesticides. Non-public health settings, microbials that may cause objects to spoil or rot. As you can see, it was cooling towers, fuel, paint, and paper products. Those are non-public health settings. However, there's also public health settings, which means the microbials that can cause people to get sick. And you can see maybe something happening in bathrooms, kitchens, homes, hospitals, and restaurants. So public health products are designed to handle the infectious microbials. As you can see here, because public health settings, there are 3 types of public health antimicrobials based on the APIC, based on the the National Pesticide Information Center. 3 public health microbials: sanitizers, disinfectants, and also sterilizers. So those are public health products that you can use to mitigate or reduce the microbial pests. So sanitizers, those are the weakest public health antimicrobials. So they reduce bacteria on surfaces. So based on the label, some of the sanitizers may be used for fruit and vegetable washing. And I actually put labeled sanitizers for produce here in the slides because while we're dealing with food safety, there's also, food contact surfaces, non-food contact surfaces, and the fresh produce. We already talked about pathogens in fresh produce. So those pathogens existing in the fresh produce. So you can use some of those labeled sanitizers to, mitigate the risk or reduce the risk that have the pathogens. But you have to make sure the sanitizers you choose are labeled for fresh produce. And also, as you can see here, sometimes sanitizers may be used on food contact surfaces, such as countertops, cutting boards, or children's high chairs. And label also will indicate how a sanitizer can be used. Sometimes sanitizers can only be used for non-food contact surfaces like toilet bowls and carpets. So here, since we talk about sanitizers used for fruit and vegetable washing, I will give a little bit of details on sanitizers in produce safety. So the use of properly labeled sanitizers, and AKA antimicrobial pesticides, in water that comes in contact with fruits and vegetables and at or after harvest is highly encouraged to reduce the risk of cross-contamination by human pathogens. For example, sometimes the produce when they harvest it, they need to use the post-harvest water to get rid of the dirt or other contaminations, for example, poops or something else. So they were just adding the sanitizers in the water so that they can wash the fruit and the sanitizers. So the purpose here is not for washing, it's for reduce the contamination of the pathogens contaminating the other parts of the fresh produce. So there are many different types of sanitizers available to use in the post-harvest water systems. A common use sanitizer, in this case will be chlorine because it is inexpensive. And however, it can be corrosive to certain materials, such as stainless steel. There's also, non-chlorine chemical options, as you can see here, hydroperoxide and other products that you can use. You can add it in the post-harvest water systems to mitigate the risks here. And also, there are many organic options available. Be sure growers check with their organic certificate certifier before they use a sanitizer to make sure it is acceptable. I know many of us probably work with our stakeholders who have the organic garden. So when that happens, advise your growers, make sure they check their organic certifier before they use any of those options. And synthetic substances allowed for use in organic crop protection can be also, found in some of those organic certifiers as well. But when you use this, have to make sure the sanitizers are labeled for use on produce. So always read the label. Not all sanitizers are approved for use in water that contains fresh vegetables and produce. As you can see here, we do have a label. There's the EPA registration number for this Ultra Clorox brand regular bleach. And on the label, it did see for fruit and vegetable washing. So if your growers who is dealing with fresh produce, those sanitizers are the ones you can choose to use. So make sure to read the label and check any local, state, and federal requirements and the registration list of approved products. And also EPA maintains a list of antimicrobial product registration. Always check, make sure you are doing the things correctly and also follow the label. So each sanitizer will have its own specific approach to monitoring. So make sure when you are using the sanitizers, you have to monitor antimicrobial treatments, including the sanitizer levels. So any water treatment, including use of sanitizer, must be monitored during treatment. So this will be required actually by the Food Safety Modernization Act produce safety rules. So you have to monitor the sanitizer levels so that no chemical hazard will be introduced into the fresh produce. So those are the sanitizers. Now we're going to talk about disinfectants. So disinfectants can be used to kill or prevent the growth of bacteria and fungi, and some disinfectants target specific viruses, and they are called microbicides. Disinfectants are the preferred public health antimicrobial for common surfaces in medical settings. They cannot use on surfaces that come in contact with food. And also, there are different products purifying swimming pools and disinfect household surfaces, such as linens, toilets, and bathtubs. So make sure you read the labels as to what surfaces you can use and how much you can use, and also, the PPE, the personal protective equipment requirements when using the disinfectants. Sterilizers, those are the strongest type of public health antimicrobial product. In addition to bacteria, algae, and fungi, they can also kill. They can also control hard to kill spores, and those settings generally will be used in medical and research settings because they require free of any microbes, especially thinking about the hospitals. In the operation room, you have to make sure free of any microbes. So that case, they have to sterilize the whole, facility or room or any kind of tools and equipment that they are using. And generally, there are chemical sterilizers you can use, and also, in addition to the chemical sterilizers, the high pressure steam and ovens are also used to sterilize atoms within the healthcare facilities or sometimes the molecular biology labs. So those are the strongest one. They kill 100% of almost everything. So here, what are the difference between sanitizers, disinfectants, and sterilizers? As you can see in this table, sanitizers kill 99.9% of bacteria, and then disinfectants kills 100% bacteria, fungi, and certain viruses, and sterilizers kill 100% bacteria, fungi, virus, and spores. And here have to make sure you notice the time required for effectiveness. That's the on the label you will see leave it for 30 minutes. That means you make sure this is the effective time. Means you apply the sanitizers or the chemicals, you have to leave it there so that they take time to take the effects. So for example, the sanitizers time required for effectiveness is generally 30 seconds to 5 minutes, which means after you apply the antimicrobials, you have to make sure that wet and contact time so that they can fully take the effectiveness as labeled. And also here, sanitizers can be used on household surfaces and food contact surfaces. As you can see, disinfectants and sterilizers are not labeled here on food contact surfaces. That's why you have to read the labels when you are using, if it's a food contact surface or household surface or non-food contact surfaces. And here I also have little video. There's a QR code to kind of explain to you what is cleaning, sanitizing, and disinfecting. There's a video there you can watch. It was produced by the extension office, so they can talk about the produce safety. If you want to learn more there, you can click the video to check. So here, just want you to know, cleaning removes dirt and soil and pathogens from surfaces, which can include use of clean water and detergent. So cleaning and sanitizing are different steps and also different concepts. So you cannot sanitize a dirty surface. Cleaning always comes first. So cleaning physically remove dirt and soil. You can use water and detergent and clean the surface. And sanitation reduces the number of disease-causing organisms to non-threatening levels. So again, sanitation will require you use the sanitizers. When you use sanitizers, make sure you follow the labels, and also cleaning must be done before the sanitizing. So disinfection destroys microorganisms and does not kill all pathogens, and the sterilizing kills all disease-causing pathogens. So always remember, you cannot sanitize a dirty surface, and cleaning always comes first. This is really important because the sanitizers cannot penetrate a dirt surface or the soil particles, so it will reduce the effectiveness when you have a soil surface or dirt surface. So these different products, here you go. Those are the list that you can find. There are chemical disinfectants. I got it from the CDC. Please do not mix any chemicals. Such as here we have alcohol and bleach. Some combinations can be very dangerous. Like I said, do not mix any chemicals, do not mix alcohol and bleach. So the bleach and the rubbing alcohol can create the chloroform. So this combination is highly toxic. It can cause damage to your eyes, lungs, and liver. So to reduce the improper use and prevent unnecessary chemical exposures, users should always read and follow directions on the label. Again, labels are the law. You have to follow the label so you don't break the law. And now, because the COVID has been rising up again with us going to the cold weather. Now here are just list of the concerns for the COVID-19 disinfectants, and all those products on the list meets the EPA criteria for use against the COVID-19. Just Google search COVID-19 disinfectants. You can find a list of the disinfectants that you can use for battling against the COVID-19. So here's some disinfectant safety for COVID-19. If you work with or are around disinfectants, those steps can reduce the health risk. So do not overuse disinfectants. Using soap and water has been shown to remove most COVID-19 virus particles on surfaces, and do not rely only on others for instructions. And we did hear people said, my boss told me I can do this, I can do that. However, what their boss told them was wrong. So always follow the labels. You have the label right in front of there. This is the case, you can see, no boss, this is not right. You have to follow the labels. And also, like we mentioned, disinfectants have a contact time listed on the label. And also, always take precautions. If the label says you have to use proper PPE, wear goggles, wear gloves, and use a ventilation system, you have to use that. Use PPE when using disinfectants so that you can reduce the skin exposure. Check the label, and also wash your hands. It's really important, hand washing your hands after you're using any disinfectant, any products, because they are pesticides. If you don't wash your hands, you may have residues on your hands that could potentially make you sick. So also check for good airflow and ventilation before using any products. Make sure if you mix the products or apply them, make sure you have a good ventilation system so that you don't inhale all those chemicals into you. And for more information, I have a website here. You can check more information from this page. So what do we need to know? So always follow label directions, and most products require applications, leaving to stand for a set amount of time, and rinsing completely with water to remove disinfectant residues. And some of the disinfectants will require the use of protective gloves when you are using it, and also cleaning before using disinfectants. So those will be basic pesticide safety when you are dealing with all those pesticides. Always make sure you follow the labels. Disinfectant products can be used in residential settings, schools, childcare facilities, and medical centers. Make sure you use those products safely and effectively, and follow the labels, and make sure you follow all the pesticide safety precautions there. So many products can be harmful when touched or inhaled. So certain ingredients pose particular problems for asthmatics and individuals with compromised lung functions. So when that happens, those products should be used in a well-ventilated area, or with the use of proper personal protective equipment, PPE, such as use a respirator when you are dealing with dust cleaning, or masks, and follow the labels for the PPE. So when addressing microorganism pests, select the cleaning product based on the need and only when necessary. So some virus can be found in vomit or stool even before a person is sick, and for 2 to 3 weeks after symptom abate. Persons cleaning classrooms or emptying trash, make sure you wear gloves and then washing hands. So while soapy water is sufficient to clean up a drink spill, it is not the best option for all jobs. For example, a disinfectant is required to clean rescue mats to prevent the spread of infectious skin disease like ringworms. Remember earlier I mentioned ringworms is actually a fungal infection of the skin. It's not a worm, it's actually a fungal skin infection. So when that happens, if the schools have ringworm outbreaks, make sure you use disinfectants to clean all those contact surfaces to prevent the spread of ringworms. So remember that disinfectants are registered pesticides, and therefore the labels must be followed in order to avoid health problems. Disinfectants may not be used on surfaces that come in contact with food until the residual disinfectant is removed. So young children are high risk for poisoning from cleaning products, including the disinfectants. So young children, because they imitate behaviors and will want to assist with the cleaning and the disinfecting. So never leave the products unattended, and do not transfer chemicals to water bottles or other containers. It is inappropriate to ask the students to clean desks and surfaces with disinfectant wipes. So here, as you can see, the label says, please keep out of reach of the children. So children are not allowed to handle disinfectant wipes or breathing in the chemicals. So always remember you store them properly, keep out of reach of children, and remember to always store products out of the reach of the children. Some of the most commonly used ingredients are asthma triggers or skin and eye irritants. That's why here, just give you a few more minutes how to maintain a healthy classroom and limit the spread of pathogens, because with the winter coming in, with the weather's coming cool, there may have some flu seasons and some other concerns of the pathogens in the classroom, or even office space or a tight enclosed community environments. How to maintain a healthy space and limit the spread of pathogens. So influenza, flu viruses are spread mainly from person to person through coughs and sneezes of infected person. So if a person might get flu, or if a person has a flu, touch the surfaces, if that surface is not cleaned and sanitized and it's contaminated, it will transmit to other people who touch those surfaces. And also clean and disinfectant surfaces or objects. Just beware, this is a job for custodians or teaching staff. It's mainly for adults, not for students. Because adults or custodians or teaching staff, they can accurately use products correctly, following all the steps necessary as provided on the label. We already talked about it. Most of those disinfectant wipes keep the reach of children. So you don't want to have students to clean and disinfect the surfaces. So here we go. Some of the virus, for example, influenza virus and norovirus, like stomach flu, can survive on hard surfaces. For example, flu virus can survive on the surfaces for 2 to 8 hours, and stomach flu can survive on the surface for over 2 weeks. So you want to make sure you wash the surface and sanitize them. So here are the brief steps. You wash surfaces with general cleaner to remove dirt and organic matter first. Remember, cleaning always comes first, and then use a sanitizer during the sanitation. When you choose the correct sanitizers, make sure you follow the label directions. There are some chemical germicides or pesticides that use kill germs, for example, chlorine, hydroperoxide, and alcohols, anything that you can use. When you choose the products, rinse with water if instructed. Some of them said, okay, leave their air dry, so you don't have to rinse them. Some label will say rinse with water. So when that happens, you rinse with water. So always follow the labels, and also use the EPA approved sanitizers or disinfectants to do the sanitation in the classroom. So also it would be really good to let your students or your workers know, stay home when they are sick. Doing so will prevent others from catching the illness. So always make sure, and for students, make sure you accommodate students with homework so that they can keep up with the schoolwork from home. And also, especially for little kids, children, teach them to cover nose and mouth with a tissue when cough, sneeze, or talk. And because the flu droplets can move through the air for a few feet, and then if you breathe in, and you may get sick. And also throw the tissue away immediately after use, and wash the hands with soap and water. So the wipes used on items that are touched often, for example, door handles, phones, computer keyboards, all those common public areas, maybe use a disinfectant wipes to clean those would help to reduce the spread of pathogens. Remember, only teaching staff or custodians can use disinfectant wipes, and do not use your students to handle the disinfectant wipes. And also people cleaning classrooms should wear gloves and wash their hands. So just a quick note on molds and moisture. So mold is a fungal growth that forms in moisture, warm areas with poor ventilation. It needs moisture and typically a carbon source to grow. So when the mold happens, you want to make sure there's no leaking faucets, and also reduce all those moistures. Mold can form spores and disperse through the air to form new colonies. As to the mold remediation, very important source will be identify and eliminate the source of moisture. If there's a leaking faucet and you want to get rid of any leaks, you want to repair or replace the leaks, and also ventilate and dry the area. Remember, mold need moisture to grow the colony. So you want to make sure it's a dry area, and wear PPEs, especially when you are dealing with mold. Some of them are poisonous. So you want to make sure you wear at least N95 respirators. Sometimes may require N99 or 100. So when that happens, always make sure you have the PPE to protect yourself, and clean the mold from non-porous areas with water, and disproper them properly. Do not throw them just into the regular trash, and dispose them properly, put them in the sealed bag. And when the mold situation is really severe, and you may want to seek a professional assistance for the mold remediation, because they have the right tools and equipment, so they can test the molds, what kind of molds you are dealing with, and those ask for a hazard remediation company to help with the mold remediation. So all in all, do what you already do, but just think of pests. Think about the quality of the learning environment directly impacts the quality of learning for custodians and general workers. Experience one of the highest rates of occupational asthma. So based on the research, Each year, the one custodian uses on average 194 pounds of chemicals per year. So therefore, custodians and teachers, they experience some of the highest rates of occupational asthma. So when that happens, make sure, the IPM coordinators, rely on them, and so that they can report the pest sightings and get rid of the conducive conditions. So you need to know before you do any work, what are you doing, what products, what are you killing, what are you treating, what concentration, and all those questions are really good for you when you are dealing with all those chemicals. Here's a risk assessment of some of the common active ingredients in commonly used antimicrobials. As you can see, the lower it is, it's the safer with the less risk. For example, peroxide are at the lowest risk. Chlorine bleach are actually on the highest risk, and they are effective. However, they are highly corrosive to human skin, eyes, and lungs, and they can damage floor finishes, carpets, clothing, and also can irritate the respiratory, can cause people sick and lung problems, and also there's a big environmental concerns. So all those, when you are choosing microbials, make sure you consider the effectiveness, also consider the risks that are associated with those active ingredients. So there are some risk reduction, choose the safer sanitizers and the disinfectants. There are safer ingredients on the market. For example, there's caprylic acid, citric acid, and also silver. Make sure you check with your state regulation to choose some of those ingredients, because some of them are registered in certain states, not in other states. For example, over a dozen citric acid containing non-food contact surface sanitizers and disinfectants are registered for use in California. So, but that's why make sure you check with your state regulations to use those. And also, when you choose those safer ingredients, make sure you check some of those, seals, for example, the green seal, the eco logo. All those would help you to it's a certification system. Make sure they get certified some way when you choose those. So hand washing with soap and water is the best way to remove all types of germs from hands. So when soap and water are not available, alcohol-based hand sanitizers may be used in addition to hand washing. So those hand sanitizers cannot replace hand washing. So when you have a chance, you still have to hand wash. So even though you use the hand sanitizers, it kills the germs on your hand, but they are still existing on your hand. So always make sure you wash your hands properly, wash your hands constantly. And here I have a YouTube. This is a video that our intern produced to teach you how to properly wash your hands. So if you have a time to check that video, hand washing. So for schools, keep a very good, effective communication. Education and cooperation between your school personnel are really critical. In schools, there are lots of different people who have different responsibilities and the roles, as you can see here. Parents, facility users. Make sure all those group of people, they have a good communication about what's going on, especially now with the flu season, with the rising COVID cases. Communication, education, and collaboration are super critical to keep a healthy schools and even office space. So it's really important. Always, keep transparent, keep communication going, and collaboration is really important. So with that, here is our contact information of me and my colleague Africa. And also we have a link to our Arizona Pest Management webpage. Thank you so much for our funding agencies for supporting our program. And feel free to contact us if you have any questions. Thank you for your attention and time, and hope you have a good day.